expandable thermoplastic adhesive. Keyword there is adhesive. 1.5 to 2 minutes and it's done. The bolting together of the tool takes me longer than it takes to lay up the part. Yeah.
You have probably seen the foam plastics before. If you look at the dashboard on your car or even your running shoes, the sole is made of a foamed plastic. Now, when it comes to composites, they are actually used to make really high stiffness material. So if you take 2 composite panels and in between you put some sort of packing agent, what it means is the end product has got so much more stiffness compared to just the 2 composite panels itself. This video goes into some foaming agents which can be used with thermoplastics, which is a bit harder, and that makes the whole thing recyclable. Check it out.
Hi, how you doing, Jason?
Good, how are you?
Yeah, really good. I came by and I heard the word thermoplastic for these and I got really curious. Tell me a little bit more about what you guys do, what you guys are excited about.
Okay, so this is our InsituCore material. It's expandable thermoplastic adhesive.
Okay.
Okay, and the key word there is adhesive. So this bonds to a lot of different substrates, but specifically to low surface energy materials, like polypropylene. Virtually nothing seems to stick to polypropylene, right?
Quick pause on the word thermoplastic. Now, most foam cores out there are made of thermosets, and what it means is even if you're using your composite, which is thermoplastic impregnated, you can't really recycle the structure because you're using dissimilar material. It's not really going to work. Now, with a thermoplastic foam core, recycling becomes a lot easier, and you'll see that in a second.
So we make pellets, and we take those pellets and we can use these directly inside of a closed cavity tool. With heat, we can expand it into any shape. So what we're doing is we're creating pressure inside of that closed cavity tool to basically consolidate different prepregs, either thermoplastic or thermoset prepregs. And you know, you can see this is a very stiff final product. You know, it's getting the strength from the surfacing reinforcement materials.
How does it grab onto that material?
Yeah, so basically, once we heat this material above like 130 degrees Celsius, that's when it will start to expand.
Okay.
And because it's adhesive, it will also start adhering to those surfaces that it's in contact with.
So what plastics can you go up to?
Anywhere from polyethylene, polypropylene, all the way up to nylon.
Okay. And what kind of customers you've been talking to recently about these?
So we've been talking to all kinds of sporting good customers, automotive, drone and UAV. That's another area that we're focused on. You know, especially for like the blades on the drones. They're very lightweight but strong. So,
usually when you talk to European customers, they're really keen on end of life. And there's multiple reasons for that, but there's also regulation coming in, which is when we design parts, we need to have within the design a way to disassemble it. Composites are complex parts. With what you have here, you could disassemble it with temperature.
So you could heat it and then peel those reinforcement layers and just be left with the foam.
Wow.
Quick one on recycling. So as far as I can tell, there's 2 routes on this. One of it, as you've just heard, is you apply temperature and then you can start delaminating the foam core and your thermoplastic panels. But another route would also be if you take the whole part and then you put it into some sort of granulator to break it in smaller bits. What you end up with is some short fiber thermoplastic and then foaming the foam core in smaller bits too. And you could use this as a compression molding filler, the whole thing put in a mold tool, compression mold it in one go, and then you have a part.
We're able to use a lot of different types of prepreg fabrics, so either thermoset or thermoplastic. In this demo, we're using a thermoset. So the InsituCore is pretty versatile, so it'll work with thermoplastic, really short cycles, you know, just enough time to heat and bond.
Yeah.
Or these longer cycles that require, you know, maybe 15 to 20 minutes at temperatures. So basically what we do is we take the reinforcement layer, so in this case the pre-preg carbon fiber.
And that's your extruded part?
Yes, this is our extruded thermoplastic material, and you can see it does not have to you know, be very precise. I'm just doing this part based on weight.
Yeah, I can
so
see.
If I was to bake this by itself, that's what the foam would look like coming out of the tool.
Yes.
But in this case, I want to make a part in a one-step bake process. So I'm going to start with the unexpanded sheet. And same thing, I'm just adding another layer to the top half of the tool. I put the tool together, bolt it together, put it in the press.
So if you were using a thermoplastic, it'd be a layer of consolidated thermoplastic that you tack together using maybe an ultrasonic system?
Yeah.
Okay,
so,
got it.
Yeah, and then you would just lay that thermoplastic base sheet in the tool.
Yeah.
We would typically heat that up to 115 to 125 Celsius for like 1.5 to 2 minutes. Take the tool out and it's done. The bolting together of the tool takes me longer than it takes to lay up the part.
That,
so But the reason why we bolt the tool together is because the foam expands with so much force that it would just pop the tool open and you would have foam coming out.
And you need a good clamping force. I suppose if you have a proper press, a hydraulic press, you could just have pins lining up and then the press does all the work. But you might have to cool it down.
Yeah, you have to cool the part down. So then I'm just going to put the tool in the heated press. So I'm just going to cool the part in water for a few seconds.
There we go. We've got a part out.
There we have our
wow, look at that.
finished part.
Look at the consolidation on it. It properly took the writing. That is so good.
Yeah, the other interesting thing is if you make a really high polished surface on the tool,
it will.
You can see that if you look on the tool surface, you can see these marks from the release.
Yeah,
we put a release coating on it. It's actually picking up that same pattern from the release coating.
Do you guys have an idea when you put your adhesive in and it's expanding, how much pressure is the adhesive generating? Are we looking something like a bit less than a bar, or approximately, do you have an idea?
Yeah, so it depends on the density. You know, so like I said, with this part, we targeted a 0.1 gram per cc density, and that will generate about 20 psi. If we go to a 0.2 density, we're at probably 45 to 50 psi.
Got it,
We have a tool where we can measure, it has a pressure transducer, and we can measure the pressure it generates at different density, so we can supply that to our customer. And if they say a very specific temperature, because it's a function of temperature as well. So at 130 C or at 150 C, the 150 C will generate more pressure.
Right. So within your control, you have end product density, and then you have the temperature. These are the two variables that you're playing with to get the right amount of pressure on this.
But you can see there's no voids or pinholes in the surface.
That's really good consolidation. Yeah, absolutely. Wow. Perfect. Well, thank you very much for sharing this. This is really awesome. Cheers.